All right, so this lesson is going to be on lathe lesson 7, and this is going to be the tutorial. So the first thing we're going to do, seeing as this is the first lesson of the course, Mastercam or CAD-CAM 2, I'm going to kind of review a couple things. So I'll say some things you may already know, but I'm going to kind of go over them just to give a little bit of a review for some people that might have forgotten. The first lesson is obviously a lathe lesson, so the first thing we need to do is we need to go and select our lathe. So we got to set this up for a lathe. I'm going to select this Haas 4-axis lathe. You could also select default. If you don't have this one, just select default. That's fine. This allows the 4th axis that I need to cut these little slots in here with live tooling. But again, default will allow you that too. So either one of those is acceptable. So I'm going to go ahead and select that. The next thing I'm going to do is I am going to come down. I'm going to go down to my planes, and I'm going to select my DZ plane. And I'm going to equals, and I'm going to start working on that DZ plane. All right, so now that I've got my DZ plane, which is indicated right here, I am going to start drawing my part. And I'm going to start with a line endpoint, and I'm going to make this a multi-line because I'm going to go all around the part. And of course, I'm going to leave freeform on. Okay, so I'm going to start with the beginning of the part. I'm going to start at the internal diameter of 1.225. So I'm going to start by typing 1.225, comma 0, and that'll be a start point for my line. Okay, and then I'm going to go to the top diameter, the largest, the major diameter, which is 1.625, comma 0, and 1.625, comma negative 0.3. Oops, hit 2 points by accident, 375, and down to 1.225, comma negative 0.375, and I'm just going to connect it. Okay, so that looks pretty good there. The next thing I'm going to do is I'm going to draw this line that I'm going to use to do my my milling. So I'm just going to insert that, and it looks like it is a 16th deep, which means it's a 16th deep on both sides. So I need to take that and multiply that 16th by 2 and subtract it from the 1.625. So I'm going to start out with a 1.5, comma 0, and 1.5, comma negative 0.375. And there is my part. Now all I need to do is just add the chamfers. Now I could have added the chamfers with this line command, but it's just so much easier just to hit the chamfer command. Looks like our chamfers are 0.042, and then just click and add your chamfer. And hit check, and there we go. All right, so it looks like we have the part drawn. Now we are ready to set up our stock and start applying tooling. What I'm going to do when I start applying tooling, I am going to program this one way, and then I'm going to show you an alternative way to program it. The way that the book tends to go through it, and I believe that's still the case. It was in the past. I don't think that they've changed it. No, they haven't. They actually do it a little bit different than I would, and I'll go through both ways here, and I'll start by basically the way the book does it. I'm not going to go verbatim, but it'll be pretty close to the way that they do it. So first thing I'm going to start out by creating my stock. First thing I need is change my stock plane and work on the same plane that I'm working on with my geometry. And stock, let's go into there. And see, that's 2 inches should work. That'll be fine. I always try to use a common stock size that I would have on the rack. And that's mainly just because, if you put something odd in here, you're not going to have that, and it's not going to rough right. So I always encourage putting something that you're probably going to have on the rack in there. Length of this is 0.375. I could add extra length here. Sometimes I use my margins. I'm going to use my margins here. And I'm just going to put in 3.0, right margin 0.01 so that I have some material to face. Again, this 3, it's just extra stock so I can hold the material. Basically, it's just extra so that I can see it cut off, make sure that it's not going to collide with anything. So I'm going to hit check. And you don't have to set your jaws up, but let's go into that anyway because it's changed a little bit in 2021. So if you're going to be using 2021, it's a little bit different. You can see this here. What you do now to set your jaws is you're going to go to parameters and you're going to set them up here. And we're going to click on outside diameter. And of course, it's 2.0. And Z, let's just go negative 2.0 and hit check. And that should be good. And we should see our jaws with our stock. That looks good. Okay. All right, so now we are officially ready to start adding some toolpaths to this. So the first toolpath we're probably going to use here, in most cases, we're just going to face it off. So I'm going to go to my turning toolpaths. Just going to click my face. And I'm going to pick my 80-degree diamond because that's generally what I'm going to use to face. A lot of times, the other things that we use to face will be like a trigon in the shop. This tool will work. You can put this in. It's really pretty similar. The shape of the insert's different, but it's not going to really affect anything if you're facing, or as long as you have the tool nose radius, it'll be fine. So I'm going to pick face parameters. All this stuff is already pretty much set the way I want it. If you remember some of the videos from last semester, I'm actually going to have those posted on the YouTube channel as well, so you can always refer back to those if you need to know what some of this stuff is. I'm not going to go over this in every video just for the sake of keeping it a little bit shorter, these videos. We don't need compensation because we're just facing, so let's just hit check. Okay, now we're facing it off. All right, so next let's rough this thing. So what I'm going to do to rough this, I'm going to actually pick here, and I'm going to extend that geometry to rough it. I'm not going to pick down here because I really can't plunge with this cutter or this turning tool because I don't have clearance on the back side of it. And I'll kind of explain what I mean there by that here in a second. Let's hit check. So if I hover over this, you can see that tool, it doesn't have a lot of clearance on the back side of the tool, so I really can't plunge it in. It's not really feasible. So I have to use a sharper tool like a 32 or 35 degree diamond if I want to do that. But I can do that with my finish pass, and that's what I'm going to do. I actually might add like a separate roughing pass to do it. So let's click here, hit rough parameters, and I'm just going to look through here. Everything here looks pretty good. Depth of cut looks good. Lead in, lead out. That looks good. Let's take a look at that actually. We're going to extend this contour here in our lead in, lead out, or particularly in our lead out. And I'm going to extend that. I'm going to extend that at least the width of my cutoff tool and also the chamfer leg and a little bit extra. So the width of my cutoff tool I know is 120 thousandths or 125. And I know that chamfer is 42. So if I just round that to 45, I'll end up with basically 170 thousandths. So 125 plus 45 gives us 175 or 170 thousandths. I'm going to make it 180 just to go an extra 10 thousandths. So we're just going to make this amount 0.18, and we're going to extend that and hit check. All right, we don't need any plunge parameters. Remember, this needs to be on. I'll show you the difference. You can see there it tries to take it all in one cut. That could end up catastrophic. So we want to make sure that we use stock for outer boundary. And let's regenerate that. And now you can see it does the multiple passes. So that's super important to remember to put that on. I definitely will ding you on points if you don't have that on. Okay, so let's continue with a lathe finish. Let's do this finish turn here. Okay, so this is where the difference is going to be. So what I'm going to do is I'm going to go ahead and pick this and here. So I'm going to pick this here chain. And I'm going to hit check. For this finish, since I am plunging here, I need to have a tool that's going to have clearance where it's not going to, the backside of the tool isn't going to gouge into here. So to do that, I definitely am going to need to use a 35-degree diamond here. So I'm going to grab that. We also call those profile tools. And I'm going to take 2 finish passes. And there's a reason for that. I'm moving this off screen here for a second just so I can make a quick point. As this goes around, there's 10 thousandths left on this part, these 2 edges here. This one here, you can see all this material's here. So when it goes and it takes a pass and it plunges down in here, it's taking a much heavier cut. And even though these lathe tools are fairly rigid and heavy duty, it still will have a little bit of deflection. And what we'll end up with is an inconsistent finish. So you'll have a nice finish here because it's only taking 10 thousandths, and then you're going heavy, and it's going to be a different finish. It might still be okay, a decent finish, but it's just not going to be consistent. So I try to get everything so it's a consistent finish. If it doesn't matter, you can easily take this with 1 pass, and it wouldn't be a big deal. But for the sake of thoroughness, I'm going to make sure that I take 2 passes. I'm going to take 2. We're not going to leave anything on the step over. We're going to make it 0.005. That way there's 5 thousandths left on the whole thing for the second pass. And, okay, so I need to go into my lead in, and this is okay. I can lead straight in. I may even extend this just 0.01 just so it starts off the part a little bit. And then I'm going to do my lead out. I'm going to extend this 0.01 as well, just so it goes a little bit past. And I'm going to change this. And the reason why is I don't like it rapiding 45 degrees when I'm cutting a 45-degree chamfer. I'd rather just come straight out. And I'm going to hit check. And then last, this is important. This whole toolpath will not work if you do not fix this. Right here, this is what's going to allow us to plunge. Otherwise, it won't cut. It won't dig in. So we can plunge in both the X and Z, as demonstrated here. You can see it's kind of showing where it's plunging in the Z, the X. This one's just the X, and this one is just the Z. I'm going to pick both because technically we are kind of plunging in both. And if you pick one of these other ones, it actually won't give you the correct toolpath. So I'm going to hit check, and I'm going to OK that. I believe we're good to go. Okay, so that looks good. That's going to give us exactly what we want. You can see the little gray line there. It lines up perfectly with our geometry, and that's what you want to see. That's how you know that the toolpath is doing what you want it to do. Okay, so that looks good. The next thing I'm going to do is I'm going to actually drill this out, and we're going to bore it. Now, traditionally what you're supposed to do here is you're going to do a spot drill, and then you're going to drill it, and then you're going to bore it. I'm just going to, for the sake of time, you should always make sure that you're using spot drills. I'm just going to drill it because I know you guys know how to use a spot drill and actually create a spot drill cycle. So I'm just going to drill this at just probably a 1-inch diameter. What is it? 1.2. Yeah, we'll use a 1-inch diameter, and then we'll bore the rest out with a boring bar. Okay, simple drill. Depth. Let's make all these absolute. I like working in absolute whenever possible. Negative 0.375. Clearance is good. Recheck's good. Drill tip comp. We are going to go through this by, let's say, I'm going to go 100 thousandths. Yeah. I'm going to go. I'm trying to think of how far I want to go through. I'm actually just going to go through an extra 50. And really, the only reason I want to do that is I realized that I did pick a spot drill to drill this out, so I really would probably want to use a different drill. Again, I did it for time, but just for the sake of showing you where the drills are as a kind of a reminder, what you would do is go into here, and they're not in lathe inch, they're in LC drill or L drills, lathe drills. And here we go. These are all our drills. So we can pick a regular drill here. Where's my 1-inch drill? Check. And all right. And let's regenerate that. You can see the tip is obviously 118 degrees rather than that 90 degrees it showed at first. The reason I went past is because I'm going to use my cutoff, and I want it to hit this diameter. So that'll be fine. Okay, so it's now drilled. Let's go ahead and add a rough pass. And let's just pick that. And of course I need to open up go back to my old lathe tools. Lathe inch, open. All right, and I think we could probably get a 3/4 inch bar in there. So always pick the biggest diameter and the shortest bar you can. Stub up the bar as much as you can and get the biggest diameter you can get in that hole. That's obviously important for rigidity. Okay, so let's rough this thing out. I'm going to change this to 0.05 because the boring bar, that probably could get away in aluminum with 0.1, but I'm going to just be a little cautious. I can always change this later on. I'd rather it be a little slow and speed it up than it smash it and have to replace something. So just be a little cautious there. Okay, so use stock for outer boundary. That looks good. Lead in, lead out. Let's take a look at that. Okay, we're going to use straight in. That looks good. Lead out. Let's extend this 0.02. Just a little bit. It's less than the extra that I put with the drill, so it's going to stop before the end of the drill. And it's also going to go a little extra so that it doesn't leave a little like razor edge when I go to cut it off. And make sure that I go past where the backside of the part is. And this retract out, that's good too. It's going on an angle there, so that should be fine. Okay, so let's hit check. And stock's good. I think everything there is good. Let's hit check. And there's what we get. Okay, so that looks pretty good. I'm actually going to extend that a little bit. You can see here, this is showing my tool nose radius. You can see it's probably a 32 thousandths radius. It doesn't go past. So these are the kind of things you got to look for. This is why we have this geometry and all this fancy verification and the simulation. You want to make sure you make use of that by looking at it. Okay, so let's go into this. And I didn't even think about that at the time when I was doing this. So I'm going to make this 0.04. Actually, I'm going to make it 0.05. I'm going to make it just match up with where I was with my drill. Because the drill's angled anyway. You can see it down here. It's angled, so it's not really going to gouge into there. So I'm going to hit check, check, and there we go. You can see I still didn't hit it, so that's good, and it's passed there. Now, when I go to do my finish pass, the finish actually compensates for the tool nose automatically. So the finish will go past if I set that the same. That's why I won't set that the same. So I'm going to make this 1. And make this 0.1 again, because we're just going to take one pass here. Lead in, lead out. We're just going to extend this 0.01 and hit check, check. And you can see there, well, nope, I didn't go quite far enough. So got to make it a little bit further. I thought my tool had a smaller radius on it, but I guess it doesn't. All right, so let's take a look, lead out. Let's make this 0.035 just to be sure. That extends past there we go. So that looks good. So you can see now our line goes past, or our gray goes past the edge. Okay, so that's finished. So we got the bore finished. We got it roughed, we got it faced. It looks like the last two things we have to do are to put these grooves into it and then cut it off. All right, so let's go ahead and put those grooves. Now, we have, in the lathe, we have some, I guess what you'd call them is predetermined cycles, or just basically ready cycles here. You can create your own doing this milling and stuff, but they're a little bit more complex, and we'll get into that in later lessons. So right now, for these next couple lessons, you're going to be using these. And if you hover over these, it'll tell you what they do. So this is a face contour, which means we'd be cutting on the end of the part. This one is a C-axis contour. This is actually going to cut around the part, so it's going to wrap any geometry around the part. And then this one here, this one is going to cut parallel to the axis of rotation, aka the z-axis. So this is what we want. So we're going to pick this one, and I'm going to pick that line and hit check. All right, and we're going to have to select our tool. Oh, that's handy. It came right up. All right. Always remember to check your feeds and speeds. These feeds and speeds actually aren't too bad. I could probably go a little faster since I'm in aluminum. I think the max spindle speed is 4,000 on the STYs. And our feed rate, we should probably be at like 0.002 per. We're going to slow that down a little bit since it's live tooling. Live tooling, you can't really go quite as fast as what you can in a mill. So 24, we'd probably try that out, see how that works. That should be okay. Okay, so like I said, we can always speed it up later without crashing something first. All right, so compensation type, we don't want compensation on this because remember, when we're doing compensation, it's going off to the side of the line. We actually want to do a center line cut on this line. So we're going to turn that compensation off and leave it off there. Obviously, no stock left on the walls. No depth cuts. This is only 62 thousandths depth in aluminum. We'll be fine. Lead in. We don't want a lead in or a lead out. But I do want to extend the contour. This contour, first off, when the bit comes in, it's going to come in and plunge straight down. And it's going to have the center of the end mill right in line with 0 here. So it's going to plunge down with half of the end mill. I want to plunge off of the part and then come into it. So I'm going to turn this lead in, lead out on, and I'm going to turn my exit and entry motion off. And then I can adjust the contour length here. So at the start of the contour, I'm going to say I want this to be 110% of, actually I really guess I only need to do 50, so I'll just do 60% of the cutter. So it's going to go 150 thousandths. I'm going to extend that. And at the end of the contour, I'm just going to extend this like 10%. 25 thousandths. That's fine. And I'm going to make sure it says extend. Breakthrough and multi-passes. We don't need any of this. Linking parameters. Okay, so where I selected the line. So I'm going to leave these on incremental. I usually do that when I'm working with C-axis. So the depth first, let's look at that. I picked this line. That is exactly where it needs to be. So that is going to be at 0. So I'm going to leave that incrementally at 0. So incremental is just saying incrementally from where your geometry is. So I'm going to leave that at 0 so that it cuts right at the depth. Top of stock, I am going to make that incremental, and I'm going to make that about 200 thousandths above. Feed plane, I'm going to make it the same. Retract, 0.2, and then clearance can be 0.25. And let's go ahead and hit check and see what we get there. All right, so now remember, these lines are the center of the tool. So let's take a look and see how that all looks. Now what I may run into is the roughing pass that I'm taking. It may hit that, and I'm going to have to just change my roughing if that's the case. Okay, so that looks good. Let's just go back here a little bit, and let's hit play and slow this thing down. Didn't make it. Okay, let's go back to there, and now let's play it. When they say slow, they mean slow. Okay, so it didn't plunge, but it did go a little further than we want. It crashed in, it didn't crash, it just milled into this very thick sidewall here. So what we need to do is just change our roughing and just extend that a little bit, so that way we don't have to worry about hitting that. Aside from that, everything here looks pretty darn good. I'd say the part looks pretty good. So let's take a look at our rough, our lathe rough parameters, and let's just go in, it's going to lead in, lead out, and let's just extend this to 0.22 and hit check. And let's regen that. Select all, regen, and let's play it now. Now we should have avoided that. Okay, so that looks good. Now it's stopping before it hits that. Would it have been okay? It might have taken it, but there's really no reason to do that because you don't want to put that kind of pressure, especially not radially on the end mill. So it's easy just to extend your rough to get rid of that. All right, so that looks pretty good. Now what we're going to do is we're actually going to transform those toolpaths. All right, so I'm going to come up here to transform toolpaths. I can either do it here or I could also do it in transform. Either one of them would be fine, but transform toolpaths is what we're going to use. Actually, no, I'm sorry. This transform will not work. Transform in here won't work. I think there's another place for this, though, that this icon is found. I thought it was in there, but I guess it's not. So you want to pick in turning. You'll pick this transform toolpath transform. Okay, so first thing we're going to do is we're going to rotate this. We're not going to translate it. It says you want to unselect. It's just giving you a warning to unselect operations that it can't necessarily rotate, or it just... we're just going to hit yes for this because I don't know what's selected, so it'll just unselect everything, hopefully. No, it didn't. It just left everything except for this. So I'm going to click this, make sure only that is selected. And next, I am going to go to rotate. It's going to give me that warning again. No, I do not want to unselect it this time. I know I have the right one selected. And now it's asking me how many instances I want. In this case, I want 3 additional. So it's additional instances besides the one you have. If you pick 4, it's going to do this top one twice. So it's just how many more you need. And I'm going to leave this on angle between because we know that it's 90 degrees between each of these. Total sweep would just put all 3 of them in a 90 degree angle. So it would basically, within 90 degrees, it would have 3 more instances. So we definitely don't want that. So 90 degrees between each one, that sounds good. And we're going to need to turn on the rotation plane. Now, the way that we want to rotate this, we always want to look at it. So right now, if I'm looking at this is the top plane. So if I was going to rotate this, it would put one here, one here, one here, and one here. But that's not what I want. I really want to put one here, here, and then one in the back there. So I would want to be looking at this from the right side, from this side. So if I was viewing it from the right side, that's how I want to rotate it. So I'm going to hit right, check, and I'm going to hit the check mark. And let's take a look. Let's go to the right side. So this is what it looks like from the right side. You can see it rotated them around. Go back to top. So if it did top, it would have did it here, 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 and of course the original. So whichever way you're looking at, that's how it's going to rotate it. Obviously left side I could have done as well. I could have picked left side and it would have did the same thing. Either one of those would have been okay. They would have both did exactly the same, left or right side. But that looks good. That looks like that's exactly what we want. So let's go ahead and take a look and simulate that. Oh, it helps if I select an operation. Select, and I don't think I need to regen. I think everything's good. Let's go ahead and hit play. Okay, that looks like business. So there is our part. So that looks good. Now, one thing that I neglected to do during this whole thing that you should do often, especially when you're testing, go up, File, Save As, Videos, Save. Yes. And you want to save this. I try to save throughout, especially when I'm doing a lot of stuff, just to make sure that if I lose anything, I can pick back up close to where I left off at least. If the computer crashes, Mastercam crashes, that's been known to happen. So just remember to save. Okay, so last thing I need to do is I need to cut this thing off. So I'm going to come up, I'm going to go to my cutoff, select boundary, I'm just going to select this edge here. And I'm going to hit groove. And I'm going to use this right right-handed or left-handed grooving tool. Oh, you know what? Something I didn't explain. I always want to make sure that when I'm roughing too, I go at least the distance or the width of my cutter. And I did tell you that when I created it, but I didn't really explain why. Let me see here a second. Okay, so if this is my part, I have to excuse my drawing here. Oops. Let's undo that. Okay, so if that's my part, and basically I've roughed back to here, and let's say I have a cutoff tool and it's like this. All right, obviously that's coming straight down, through here. What I don't want is I don't want the edge of this to hit, because what's going to happen when this hits, it's going to deflect to the right. I want to have this completely cleared out. That way I don't have to worry about this thing deflecting. And it will deflect. Very easily it can deflect. So what I really want this to look like is I want this to look like something like that. Now I don't have to worry about this deflecting because it's just hitting this flat surface. So that's the reason that that we do that. So that's something to think about. Why why you're going to have to rough this further than you really need to. And of course, we wanted clearance for our finish tool, and of course we needed clearance for that end mill too. So actually I ended up extending it further for that reason. Okay, so moving on, right here I'm going to use my 0.125 tool. Notice I'm not using this one because this here could very easily gouge the stock, the left side of this. I want to use this one because it's straight on the left side. I'm not going to hit my my part because I know better. Basically, I know what this tool is, and I don't have to worry about hitting my part. All right, so first thing, entry mount. I'm always going to go from stock. Always. Retract, always going to go from stock. I shouldn't say always, but most of the time I'm going to go from stock. I hate to use always because that is not always the case. All right, so next I'm going to make an X tangent point. I'm going to have it cut down to here. And that looks good. So basically this is just the min diameter. That's where it's going to go down to. Since there's a hole in it, it doesn't need to go the whole way to 0. One other thing I want to check. I want to make sure my stock update. Keep piece and action. Okay, that's the exact one we don't want. Either of these is okay, but that one, if you have that one selected, I will take points off. And I'll show you why here in a second. Actually, you know what? Let me let it on so I can show you a little bit better. I'll show you how stupid it is. All right, and let's hit play. Okay, well, where's my part? I can't even see what I did. Like, I'm not even seeing if my part is okay or not, if it turned out all right, because it disappears. So if you have that turned off, that tells me you didn't even check your work. So that's the biggest reason why I take so many points off for it. So make sure you have one of these. And I usually generally like both pieces just to see if there's any crashes on the stock itself. Because if you cut this, uh-oh, the heck was that all about? Okay, that was weird. If you cut this, you might not see, something over here that it might crash into or something like that. But now I can see there's no red on this. This part looks great. Everything there looks exactly as I want it to look. You may have noticed that One of the things you want to check is that your geometry lines up with the edges of your part. You notice that this one doesn't. Well, that's just because I removed this slot. If this were to continue on, it would go right through there. So that is just fine. So that is it. That is the way that your book has you do it. Now, I'm going to show you a little bit different way to do it. And this is the way I do it because I think it's honestly a little bit easier. At the moment, I'm going to leave my cutoff in here. I'm going to have to change a bunch of things around. So I'm going to save this right now. And I'm going to go through and I'm going to go to Lathe Rough. And the rough, I guess, is okay. Yeah, the rough is okay. And I'm going to go to Finish. We're going to change our finish path. And I'm just going to select Rechain All. And I'm going to do this. Hit check. Check. And we're going to go to Parameters. We're going to make this one pass again. 0.1. And I'm going to change this to 0.2. And we're going to change that. This no longer needs to plunge, so I can take that off. And I'm going to hit and regenerate that. Okay, so now it's just cutting right to there. It's not doing any of this other stuff in here. I'm not sure why the lathe drill has an issue with that. Let's regenerate that one. Okay, drill is good. I just need to regenerate them because it was goofy. Generate the finish there. All right, so that's all good. And so I think everything there is pretty much good, except for probably the cutoff. Oh, even the cutoff worked. Cool. All right, so now if I run this, so now you see the part, well, it looks good, but it's missing our chamfer. And that is going to be a bit of a problem. Now, there's a couple of downsides, things you have to think about. So, like I said, there's two ways to do this, and it depends on how rigid and how stubby your cutoff tool is. Because this will be an interrupted cut because of these notches in it, it may be a problem, but we're going to use the cutoff tool. I'm going to show you another way so we can use the cutoff tool to put that chamfer on there. So let's first off add some geometry here. What I really need is I need a theoretical point here. So I'm just going to go and hit enter. I'm going to do it like this. And I'm just going to clip these. Okay. So when you're doing a chamfer, you have to pick this theoretical point. You can't pick here. You can't pick here. Actually, there is a way, but it's a pain in the butt. But you really want this theoretical point. So I'm going to pick my chamfer again. Actually, check that. I'm going to pick my geometry. I'm going to pick this point up in that corner. I'm going to regenerate that. And I'm going to go to Parameters. And I'm going to go into my cutoff parameters. And I'm going to go to Corner Geometry. I'm going to say I want a chamfer, and I'm going to go to Parameters, say 0.042 is going to be my chamfer, check. All right, now, one of the things I want you to know is that this is not going to work, and I'm going to play it because every student has trouble with this, and they forget about this, and even I forget about it, so I've done this and kind of scratching my head for a couple minutes thinking, what is going on here? And then it dawns on me what I did wrong or forgot to do, I guess. So go ahead and regenerate. Okay, we have a problem. Collision with stock. Okay. So when you get that, right here's what happened. You forgot to hit clearance cut. And we can control this clearance cut. I always make sure from stock's on just in case there's some stock up here. And let's hit regenerate now. All right, so that looks a little bit better. Okay, so now let's go ahead and run this. And that looks pretty good. So there we go. So the other thing this does, since this clearance cuts it, you actually can change your roughing. So your roughing only comes just past the part now, because it comes in and plunges this out, gives you enough clearance to make this cut without plunging on a diagonal. But that is generally the way I do these things. For this one, I might not, though. I was earlier when I said I'd do it that way, I wasn't really thinking about these grooves being in here. The cutoff tools aren't very rigid usually. You could probably get away with this because it's aluminum, but generally, if you have an interrupted cut, it's going to cause some problems here. You want a nice sturdy tool to put that on there, and plus we were putting it on there with a finish tool before we even put those grooves in, so that would look much better. I think that the way the book does it is probably the best way for this part, but this is another way you can do it. So I just wanted you to know how you can put the chamfer on there. This is great when it's not an interrupted cut. Okay, so I believe that is all. I think our part is complete. So as always, if you have any questions, feel free to contact me during my office hours or in class, and I'd be happy to give you a hand with any issues that you might have.